Welcome to the conclusions episode of the online classroom. In systems engineering design, we looked at the problem from a very customer requirements orientated perspective. In systems engineering analysis, we've looked at our systems from a number of different perspectives, namely the human factors, Q theory, multifactorial design, life cycle analysis, energy mass balance, and the economic analysis. In each of these topics, we've taken some data to perform the analysis technique, and this should influence some design decision, which then could generate some more data and let us undertake another analysis. Throughout the online classrooms, we've been comparing the possibility of buying an internal combustion engine car or a battery electric vehicle car. In the back of the envelope estimation topic, we found that the electric vehicle was an okay alternative, provided you could get a daily recharge based on the amount of driving that needed to be done each day. We also found that it might cause trouble with longer travel, as its range is quite restricted, about 160 kilometers. From the diffusion of innovations topic, we found that we would be a very, very early adopter of the technology in Australia, and that this could have some associated issues around early technology adoption. In the humans factors topic, we found that both cars are probably fine for 2 adults, and probably 2 children, but it would probably be a squeeze in both cars for 4 adults. So if we needed the car to fit 4 adults, we probably need to look at a range of larger cars. In the Q theory topic, we established that electric vehicles need to be faster to recharge and discussed the possibility of an alternative refueling method, such as charging when you're at home and work, thus not taking any time out of your day to recharge. In the multifactorial design topic, we found that there are many ways to improve the efficiency of a car, and reliability is one of the keys to improving adoption. In the life cycle assessment topic, we found that the impact of electric vehicles is low at the moment because there aren't many people using them, but we should probably be concerned about the batteries if there was to be widespread adoption. We also found that the energy source is a key to understanding the overall impact of a design, and that embodied energy is difficult to quantify. In the energy mass balance topic, we found that the electric vehicles have less mass and energy flows, and we could extend our understanding to consider the electrical source for the electric vehicle. In the economic analysis, we found that cars are pretty much just expensive, and that there were opportunities to reduce the upfront costs by exploring second-hand alternatives, or perhaps we could look at the feasibility of converting an existing car to reduce the overall life cycle cost. In each of these topics, we've taken data to inform some analysis, which informs some design decision. When you go about constructing your portfolios, ensure that you go through this cycle where you're taking data to inform your analysis, however you might apply that analysis technique, and ensure that it informs the next stage of your design. Remember, the online classrooms were largely conceptual, and to demonstrate a good understanding of the topic, you'll need to work at a level of detail that might require you to go through this cycle a number of times. Thanks for watching the online classrooms, and I hope this was useful in preparing your portfolio. Thanks for watching the online classrooms, and I hope that these were useful in preparing your portfolio and also to understand the role of analysis at a systems level.